Hello, 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 hello,
Hello,
hello.
hello, hello, hello.
Hello?
Hello, hello,
Hello,
hello,
hello.
hello.
Welcome.
How we doing? How we doing?
I'm doing good. How are you doing?
Doing
Like
good?
if we weren't just talking right now.
Oh man, I'm a little tired, but we're here, bro. I'm excited for this stream. This stream is a good one. It's a good one. You know, it's pretty nice. I feel excited and see how we do. How we do.
I guess right off the bat,
me
let me do some introductions. Everyone, as you
Oh
can
yes,
tell
yes, yes, yes.
by the title, we have a freshman here, and I hate saying that. Like, I remember in high school, like, oh, you're a freshman. Like, oh, like, it's nothing like that. But it's just like you are a freshman, right? So I'm not here to bully you, though. Okay.
Yeah.
You are a freshman.
Yeah.
You're new to the degree catalog, right? So
Exactly,
this
yeah.
freshman, please introduce yourself, man.
So I'm Simon, freshman, UTSA.
Whoa!
Yo,
You can't say
we
you can't say the
bro, we
school.
forgot to be
I can't say that.
armed, bro.
No, you can say it. That's
Bro.
okay. That's okay. Keep going.
Bro, come on. I thought I was like doxing you guys.
Yeah, you are
not
basically, but
secret.
it's okay. All right, keep going, Mr. Simon.
Yeah, so I'm in the Rowdy Creators Club at UTSA, and that's how I met these guys. So they're gonna teach me how to do some LeetCode problems.
Have you done any LeetCode prior?
Never done LeetCode before.
Okay, perfect.
Just done some Python. Learned some Python and like some other basic languages.
Mm-hmm.
Not too much.
And what interests you about this degree? Like, why did you get into it?
Mainly because I like computers and I like to figure out, how it all works, and I think it's all like very interesting to me.
Mm-hmm.
And the pay is great too, so
Okay. Money motivated.
can't complain about
A
that.
little money motivated too. Nice, man.
A little bit, yeah.
Well, first of all, I want to say thank you for coming on. Obviously, LeetCode shouldn't be intimidating, but it can be for folks that are new and stuff, and they might not know like much things, or like they look at the problem and they don't really know where to start. So we think you're in good hands. First of all, you're in good hands with us, right? We're gonna guide you through. We're not gonna throw you and like wait for you to drown. No, we're gonna be there with floaties for you so you don't drown. Okay? We're your floaties for today.
Alright.
And our goal here today,
Alright,
everyone, our goal here is just to introduce it to him. Like, if he could solve it on his own, then clearly someone lied to us. That maybe he's done LeetCode before, maybe. But basically, we just wanna introduce it to him, build some confidence. He's a freshman. I know some people that like, including myself, that's never done LeetCode, like not even freshman year, right? Like, I didn't start LeetCode until like I guess technically it would be junior year. So I think this is a really big thing for Simon to get like a little head start. To get it seems like he really likes it too. So I think we found a perfect guy to bring on the stream and just kind of teach him a little bit of what we know about LeetCode and see how he enjoys it. Jose, anything you want to say?
Nah, dude. We're excited to have you, brother. And like Carlos was saying, we're like the training wheels. When you're learning a bicycle, we're training wheels. So we're gonna do our best to teach you some topics, and then teach you how to use the topics and LeetCode, and introduce you to LeetCode. That way you can feel a little bit more confident and to go in there and jump into LeetCode and see how far you can go. And yeah, we just want to give you that jump boost, right? And yeah, man, I'm excited. Hopefully you like it.
Yeah.
Perfect.
Yeah.
Let's see, if everyone who's watching, we have 7 viewers, please comment, give us some feedback, give us some criticism, like if you like the stream. We'll be streaming for the next hour and a half. We stream every Wednesday, 8:30 Central Time. So, wait, actually, We post videos every Wednesday, 8:30 Central Time. We have something in the works, so we're just gonna keep it. That's a little hint right now, okay? So let's get started. I just wanted to show y'all our YouTube channel right here. We're 6 subs away from 600.
Subs, man.
We've
6
live
subs.
streamed for consecutively for a year. We took like a 4 to 3 month break. Now we're back at it, ready to learn. Me and Jose, we're even trying new stuff. We're bringing in freshmen. We're bringing in buddies. We're trying to make everyone a better problem solver, better programmer. So if you like that, you like this channel. All right, I think that's it for now. Am I missing anything, Jose?
Yes, we got 6 to 7 people watching the stream, and we only got 3 likes. Come on, man. Come on, bro. Come on, bro. All right, we got 4 likes now, and we still got 6 people watching. So, there's a little discrepancy in there. Yeah, like it up. Thank you, Simon. Thank you, Simon. Thank you.
Okay.
Like it up.
Perfect. Okay, Jose, I guess you're gonna lead this. I know you had something planned for Simon. Did you want me just to go to the problem, or what do you think?
Let's go to Excalibur. I want to do some drawing. That way, we can go a little bit on the basics, how things work, and all that stuff. First of all, and yeah, man. All right, let me know when this.
I think you're good, and also I need a stream on Discord.
Oh yes.
There you go.
Okay, that way we can. Okay, perfect.
So tell everyone what we're gonna be covering today, Jose.
All right, today we're covering stacks. I was talking to Simon a little earlier today. Asked him if he knew what stacks were. He said he knew about the concept of stacks, but he didn't really know it like in depth. Correct me if I'm wrong, Simon. But today we're gonna cover a little bit of stacks. It's not full on dive. We're just gonna teach him how it works, different applications, different analogies that you can think of, how to implement it in Python. And after that, we got 2 problems. One easy, right? Well, both of them are easy according to LeetCode, but one of them is like really beginner friendly. That way he can get his toes in the water, right, to feel what LeetCode is, and implement stacks. And the second one's a little bit more challenging, but it is really good one for a starting person that's like getting into LeetCode. That way they feel a little bit more of the LeetCode experience. So let me see if I can move my screen onto where your guys at. Damn, I don't see you guys. Are you guys here? Oh yes. I'm here. Okay. There. Okay. So stacks. Card is saying. So Simon, what do you know about stacks? What is like the first thing that pops into mind? You can draw it, you can change it, whatever you want, brother.
Yeah, so all I know about stacks is that it's like last in, first out. So like you can push something on top and then keep stacking things, and then you have to take from the top. So like you can put I don't really know like what like data types you can put on top.
Gotcha. Yeah. Okay, yeah, you got that right. It is a last in, last out algorithm, where the first element you put in is the last one you get out, right? So the way I'm gonna present you stacks is pretty much like a stack of books, right? Where we have like a bookshelf, right? In this case, let's say I have like a list of books, right here. We got Harry Potter, right? Percy Jackson, Game of Thrones, all those different books, right? And the stack kind of is like a little bit like self-explanatory, right? Like you said, like the definition you said, right? Where you get a book, right, and you put it inside. So you get the book and you put it inside, right, into this stack, right? And you're kind of stacking the books one on top of each other, right? So you got the Harry Potter in, and then you get the Percy Jackson book and you put it on top of the stack, right? Or in the stack of books. You kind of create this stack of books, right? And then you put the Game of Thrones, all this, into this form, right? And like you said, it is a last in and first out, right? And the reason it is that is like, yeah, like I said, it's a stack, right? A stack of books, stack of plates, right? If you want to get to the bottom of one, right, you have to remove the Game of Thrones one, you have to move the Percy Jackson one until you get into the Harry Potter book. So that's a little bit of that, right? Carlos, also feel free to jump in if I'm like not
Yeah.
explaining anything.
No,
You
I'll
know,
jump
feel
in.
free.
I'll jump in wherever. Oh, you're doing great.
Yeah. All right, bet. So yeah, like you said, Simon, you can think of it like a stack. You know, you're putting things on top of each other, right? And there's different functions that you can do, but two of them, the primary ones, is push and pop. Right? Push means you're pushing something into the stack. So, like in this case, we're adding a book onto the stack, right? Pop means that you're removing an element from the stack. Since this is a last in first out, you're popping from the top, meaning you're getting from the top of the stack. And so yeah, let me see, check my notes if I'm okay, yes. So are we good up to here, Simon? Are you yeah or nay?
Yeah.
I
guess
yes. Okay. So yeah, that's pretty much a stack, right? The stack is something they put things on top of each other, and if you want to get to the next element, you have to pop on the top, right? And so on and so forth. All right.
If I could offer some input.
Yes, for sure.
Just to give like a real world example of what you might use a stack for, it's kind of like you know how you do Control Z on your keyboard, and then like it reverts back to what you previously did and stuff like that. Imagine a stack.
Yeah.
So like it will store all the actions you've done, and when you press Control Z, it literally just takes off the last action you did, and then it takes out the stack. So now you're back at the previous action. Does that make sense?
Yeah, like you pop off the last action you did.
Mm-hmm.
Exactly.
Yeah.
That's pretty much. Yeah. Yep. Yeah. So yeah. Oh, another example that I was planning on telling you is parentheses. I don't really want to give you them, like I was gonna give you the example because it's related to a problem, but I'm gonna let you figure it out once you're at the problem, because I think you are getting like grasping the concept of a stack already pretty good. So yeah, so in order to implement this stack in what's it called, in Python, right? There's various ways. Well, there's primarily two ways that all revolve into a list, right? Which is the way you create a list in Python is you first name it, and then you equal, right? Let me change to a different color. Let's go with blue.
Did you want to type it
let's
out, or was drawing it out better for you?
Yeah. Let's type it out. That way we can differentiate which one is which.
I'll help you out here with organizations.
Yeah. Thank you. Oh my god. Okay, there you go. Okay. So you would say, okay, so now that you understand stacks, how do we implement stacks, right? So to implement stacks in Python is pretty simple. There's two ways to do it. One of them is using I think it's a library, and the other one is using just Python by itself, right? So, and right now we're gonna go why they're both different, but both of them revolve around using lists. So you said you were familiarized a little bit with Python. Do you know how to create a list and stuff?
Yeah.
Yeah. Okay.
Do you know what a list is?
What is that supposed to mean?
Like, do you know what a list
Just like
is?
a collection. Yeah, like just like a collection of like integers or strings or floats.
Nice.
Yeah,
Okay,
pretty
cool.
much. Yeah, pretty much. So, like you said, the stack is a collection of whatever, integers, strings, characters. I think you can even do tuples, nodes, all stuff, right? So in order to implement a stack, we can use a list, right? And a list provides us with two functions, which are stack.append, right? Stack.append. And so stack.append, pretty much what stack.append means, you append the element or the value inside the parentheses onto the stack, which is on the back of the stack or back of the list, if that makes sense. So for example, if I do append 3, I'll get a 3 in the list, and if I do something similar again and I do 4 or 5, I get a 5 on the back of the list. So that's pretty much what append is. It just adds an element to the list, pretty much. So now, and then list also gives us a function called pop, right? So like we mentioned, pop is pretty much works as the pop in the operations, where let's say we have a couple more values, right? When we run pop, right, this thing is going to remove the last element of the array or of the list in this case. So if I do pop and then I do stack.pop again, right, it's gonna remove the last element of the list, pretty much, right? And the cool thing about pop is that it returns, if I'm not mistaken, it returns the value. So let's say I do pop.6, right? If I do 6, and I do something like that, let's call it x. This pop is gonna remove the 6, and x is gonna equal to 6. So pop returns the value it removed from the list, which can be pretty useful when you're traversing some sort, and you need to access a specific element of the list and do something about, you know, the recently popped element. Yeah, so this is how the way you can implement using Python natively. There's also something called, let me see if I can put this a little bit more. There we go. Called collections, which is a library in Python that includes the function called dequeue. So this collection is a library in Python. Thankfully on LeetCode, I think all of them, if not most of them, most of the libraries are imported already, so you don't have to worry about importing them or looking for how to import specific libraries or so. They're already imported for you, so you can just do, you know, you can skip that part. But dequeue pretty much is really similar, really similar. The only difference is how we create the list, right? So in order to create the list, right, we can do something called stack equals dequeue, which pretty much creates a list that can be accessed from the end, right? From the beginning and end. So it's like a two-way list. You can add at the beginning, pop at the end, and then you can add at the end and pop, you know, you can do add and remove in both sides, right? And as previously, nothing pretty much changes here. You still have the same functions, right? Where append you add to the end of the list, and pop you remove from the end of the list. The only difference is as dequeue, it's of O of n, right? Which is a little bit more faster. So the removing and the adding of elements, it's constant time, which means it's like immediately, you know, it's like really fast, right? The contrary, stack, I believe, is O of n, right? Which is a little bit more slower, right? So right now we're not going to go into much of the complexities because our focus is more on stacks, but O of 1 is a lot more faster than O of n. O of n pretty much means that in order to append or pop a element in the stack, I have to traverse the entire list towards the end and then remove or add. Right? O of 1, I don't have to do that. I just go to the position I want to, to the index I want to add or remove, and just do what I want, and boom, I don't have to traverse the entire list. So that's pretty much the difference. Collection's a little bit more faster, stack is a little bit more slower, but essentially they're pretty much identical when it comes to implementing them. Questions?
Can I clarify something?
Yes, you can clarify something. Yes.
The reason why when you're using stacks with DQ is exactly what Jose said. You could pop from the front. So use the same list that we have here. Instead of using pop like this, and then it takes the number 5 and removes it, you could say pop left, right? Those are built-in functions, and it will remove this element from the front, right?
Yes.
Right. So with lists by default, you could still use a stack.
Yeah.
With the list, but the thing is, like Jose was saying, these functions have to traverse all the way to the end of the list, and this list only has 2 elements. Let's say you had 1,000,000 elements in a list, right? It would have to go all the way to the end of the list in order just to pop something or to add something at the end. What this queue does right here is, instead of going all the way to the end, you could literally just pop from the front. So so your starting point, you could literally pop right there, boom. You could literally append in the front too. So that's why using a DQ offers more benefit. So instead of like you adding the stack from the back, you can add the stack from the front. If you could visually see it.
Yeah.
Does that make sense?
I get that. But one question, like, could you pop left just in native Python without the collections module?
Yes.
If you do that with a normal list, you would have to shift over the elements, right? This queue is a different. It's like a, what is it? A linked list or something, right? But under the hood,
I think
this queue is like a linked list, I believe.
Okay.
Yeah, I believe so.
Right. So. Yes. I don't want to like dive in or confuse you or dive into the rabbit hole, but basically this is made using a different structure than a list, and it allows you to do those pop left, append to the front functions that a normal list wouldn't allow you to do.
Yeah.
And to your question, Simon, yes, you can add to the front, you can pop from the front, but the way a normal list works in Python, at least, you would need to shift over the elements because it would just mess up, like it would mess up the indexing.
Yeah. I was gonna say, like, then your indexes would all be messed up. So
exactly.
Yes.
Okay. That makes sense.
Yeah. So
I was wondering, why would we use a whole entire like module for that whenever it, like, you can just use the lists in Python, but it makes sense now.
Yeah, because like Carlos saying, collection uses I think it's a linked list, I'm not mistaken. I think so. And so like Carlos was saying, since they use like that data structure, collections is like way faster when it comes to, you know, adding and removing elements and stuff using a simple list.
But you could totally just do this. You could totally just keep it like this. Or like this is like the more advanced, like Jose was saying, if you know like time complexities, that's when you would this is like an obvious answer right here. Is choosing this one. So go ahead, Jose. Sorry.
Yes. So just to go a little bit of an overview, right? Because right now our primary focus is stacks. I just want to say that stacks, you know, are used once you get into like more data structures and algorithm. There's something called DFS, which is depth first search. This depth first search is an algorithm, a traversal algorithm, right? So just to go an overview, this traversal algorithm pretty much is used to go like to traverse a binary tree or graph or something like that. So it is pretty awesome, right? And this DFS, it uses stacks, right? Or uses stacks to implement DFS. So pretty much, right? Are you familiarized with binary trees? Any chance?
I am not. No, I have no idea.
Okay, so just to go a little bit overview, because I don't want to, deviate myself. So let's say you have a binary tree like this, right? Boom, boom. So pretty much a binary tree is it's made out of nodes, right? And each node has a value, and there's various different binary trees, right? And each node has a left child and a right child, which have more nodes, pretty much. And just to DFS is used to traverse these binary trees and stuff, and DFS uses stacks to implement that. So I just want to leave it at that. I don't want to confuse you a lot more. So whenever you see DFS, think of stacks. And yeah, that's just an extra tip for later on LeetCode if you ever run into trees or traversals, pretty much. Yeah. So anything that I forgot, Carlos? Any little detail?
I think that's a great start. Yeah, this is a great foundation, and not everything. This is not like everything, Simon.
Yeah.
So that's up to you if you want to go a little bit more in depth into it on your own time, or maybe there's another stream where we bring you on and add more info. But this will give you a really good foundation of what stacks are, how you could use them, what are the main functions of a stack, right? And we gave that real world application example as well. So before we're done with this, before we move on, Simon, you have any questions? We go to your first problem.
I don't think so. Actually, I do have one question. Depth first search. How exactly, or I mean, I guess, I don't know. How exactly would it traverse a tree like this?
Gotcha. Okay, so depth first search pretty much, in essence, is gonna grab this node. It's gonna start this node, and it's gonna take one of its children, and then it's gonna this node is gonna take another children, and then it's gonna go over here. All right. I forgot this. Yes. Oh man, bro, my drawings are horrible today.
It's okay, man.
Production. No, I'm kidding. Yeah, let's do one. So, the way it traverses, the the binary trees is that each of these are pointers, right? So that's why before stream I mentioned C and pointers and all that stuff. So yeah, this node is in one piece of memory and has two pointers that point to other pieces of memory, which are these two nodes. Those pieces of memory hold three things: a value, it could either be integer or a string or whatever, and two pointers, a left child and a right child. The left child points to another node that has the same thing. Three things: value, left, and right pointer, right? That point to the children, and all the way like that. So the way DFS traverses this is that it goes into the first node, it takes the left children, goes to the other, right? The other children, the other node, and then it goes to the left, it gets another node, and then goes to the left, and then gets another node, right? And then once it reaches the end, it will go back up to the previous node and then go to the right children. And then once it traverses all of these sections, it's gonna go back to the original node, and it's gonna go to the right and then left. And it's gonna go back and to the right. Once this is finished, it goes back and then to the right, and so on and so forth. Depth first search means that it's gonna grab a children, either left or right, and it's gonna go all the way towards the end. Right, so in this case, we grabbed the left and we went all the way towards the end. And then we went up, and then we went right. Then we went up, and then we went right. So that's kind of the thing, that depth first search. I think of it as depth, how depth it is, how far down it goes, right? So pretty much, depth first search just goes and takes one pointer, and it continues to use the left pointer, it reaches the end. So yeah, that's how it traverses. It uses pointers to go to another node, and depth first search just grabs one, and it goes all the way towards the end, goes back, and then all the way towards the end to the other side, pretty much.
Okay.
Yeah.
That makes sense. That makes sense.
Yes. Okay. Bet.
All right,
Alrighty. So, we ready
everyone.
for some leak?
We just did the
Alright.
introduction stage. Now we're ready to get into the actual problem solving. So Simon, like Jose said, are you ready, man? You feel good?
Ready.
Perfect.
I feel good. I feel
Alright.
good. I feel
All
ready.
right.
Let's go to the first
Alright,
Let's
one.
do it.
Oh boy, oh boy.
Can you create like an invitation link? If
Yes.
possible?
I'm gonna share y'all this link. And then Simon, you could get on the link too.
Hey, don't be nervous, Simon. Don't be nervous. Don't be nervous, my guy. You know, we're here. We're here. You can ask questions.
Yeah.
Okay.
I think.
Okay.
Yeah. Don't worry about DFS right now. That's you're not gonna see that right now. You're gonna.
Yeah. It's
these
just
are very easy.
another.
Good introduction problems and stuff like that. So how do we want to do this? Do we want to have him read it, have him go through it, or we do this one and then we let him try to do it on his own on the next one? What do you think?
Let's see. I think the other one we can help him because it's a little bit more complex. This one, I think, we can guide him a little bit less.
Okay.
Right. But yeah, I would say Simon, if you feel comfortable in reading the question, that way, you get a little bit and stuff, and from there we just continue on.
Okay.
Yes.
All right. You ready?
Yeah,
We're ready, man. We're excited.
All right. Okay. Let's do it. Clear digits. You're given a string F. Your task is to remove all digits by doing this operation repeatedly. Delete the first digit and the closest non-digit character to its left. Return the resulting string after removing all digits. Note that the operation cannot be performed on a digit that does not have any non-digit character to its left. Okay, example 1, S is equal to ABC, output is ABC, there's no digit in the string. Input S equals CB34, output is nothing. Explanation, first we apply the operation on S2 and S becomes C4. Okay, so it removed the inner 2. Then we apply the operation on S1 and S becomes nothing. Okay.
Yes.
Let's see. Constraints 1 is less than or equal to S dot length is less than or equal to 100. So length has to be in between 1 and 100, including. S consists of lowercase English letters and digits. The input is generated such that it is possible to delete all digits.
Nice.
Okay.
Nice.
I think this is making sense.
Okay.
What's going through your head?
I'm still trying to understand like what it's actually like doing.
Okay.
Because in this one, like, I think it's based on the. I don't know if you can see my cursor on LeetCode, by the way.
That's okay.
No. Okay. Well, I'll explain it. Like in the example 2, like the B, it's taking the B because that's the rightmost letter, and then it's deleting that letter and the number next to it. Seems like that's what's happening. Oh no, it says it's deleting the first digit and the closest non-digit character to its left.
Okay, I see. Okay,
Perfect.
that makes sense. Yep.
Okay, so it finds 3, and then it deletes 3, and it deletes B because B is right next to it on the left.
Yep.
Okay. That makes
I
sense.
have a big smile on my face. You're doing great.
Yeah.
Alright, let's see. And then return the resulting string after removing all digits. And I have to remove all the digits. Operation cannot be performed on a digit that does not have any non-digit character to its left. Oh, okay, wait. So that means that if there's like more numbers.
Mhm.
Or wait. Like if there's like, I'm trying to think. If
You
there's
can.
like A, B, C, and then like
Uh-huh.
3, 4, 2, 3, 4, 5,
Yeah.
then it'll delete this. Then
Uh-huh.
it'll delete this.
Yeah.
It'll delete that, and then you're left with 5.
Perfect. Yeah.
Because operation cannot be performed on a digit that does not have a non-digit. Oh, or does that mean? I'm trying to think this out.
I think you got it.
Okay. Yeah, I think you got it too.
Yeah.
Yeah, because like you said, like if you found the digit, right? The first digit, and then what's the closest non-digit character to its left? There's none. So you can't perform nothing. You can't delete it.
Yeah.
Yeah. Okay.
I think that's perfect.
Yep.
My next suggestion seems like you know the operation now. Like you kind of understand like what it's asking, right? What does it want you to return again? Do you understand that?
It wants me to return the string after I've performed the operation as many times as I
Perfect.
can perform it.
Yeah. My next suggestion would be, do you think we should go in Excalidraw and then see how Simon could translate this into a stack visually?
Yeah, that would
Alright.
work pretty good. Yeah,
Okay,
yeah.
perfect. I'm gonna go into Excalidraw then, and I'm gonna paste the photo. So we could go
Yes.
like under. I can move this right here. I can move all this, and then we'll put the photo right here in the middle. So let me get the photo out. 1 second.
You got it, Simon. That's pretty good. Pretty good. You understood the problem really good. So, I'm excited
Alright.
for you. And I think you got the dynamic going on, how the problem's working on. So you're very close, very close.
I'm feeling good about it.
Bet. That's good. That's good.
So here's the problem we're doing for the folks that are joining. We have Simon here as a freshman in college. Never done LeetCode before. We're trying to get him to do his first problem. We introduced stacks already, and now it's time for him to complete his first problem. So right now he's gonna visually draw out how to solve this problem using stacks, and let's see how he does. All right, Simon, we're here for you, man. Give us an example.
right.
What are you thinking?
Okay. I'm trying to figure out how to draw this out.
So imagine
So,
I'm gonna
I mean, I
give you a
kinda-
tip. This is your stack.
Alright. Okay.
Yep.
Sorry, maybe I should have just let you do it. I'm so sorry.
No, that's fine. Here, I'll put that a little bit to the side.
Okay.
Where's my... Okay. What's that one? Okay. So, first, the stack is gonna have... I'm trying to think if the stack... let's see. How do I undo? Okay. If the stack starts out with like everything kind of all at once, so it'd have what is it? C, B, 3, 4.
Yeah.
Okay. So if it would start out like CB34, and then I have to, I don't know how to traverse this. Oh, actually, okay, I see what you're saying, like how depth first search would play into this a little bit, because I would kind of like go, what is it? Like I would go down the list, or go down the stack until I find B. Or no, but that's...
Yeah,
Not how
depth
it
first search, it's something else. I would say focus more
Okay.
on stack. Yeah. In this.
And also, for another hint, focus on. I'm gonna bring them in. Remember the operations on a stack. Okay. So Jose told you You have append, you have pop, right? Push is basically append. So I'm gonna just
Yeah.
add I can't really draw it out.
Damn.
Maybe Jose, you could do it.
got
Push
it.
is append. Pop, you know what pop is, right? So,
Yeah.
with that being said, keep going. So,
Okay.
yeah, sorry, keep going. I'm gonna let you do it. Whenever you get stuck, if you get stuck, we're here. Let us know.
Well, the only question I have is that, am I right in thinking that, what is it, the stack, like, is initialized with all the values in the stack, or, like, is that the right conclusion?
No.
Not quite.
No? Okay.
Not.
I think
would say
stacks. I think for you and in general, stacks are never initialized full. You gotta populate it. Like the list
Yeah,
is always
there's-
gonna start. Like this is a stack
Empty.
visually, but remember in Python, it's gonna be a list like this. So it's empty, right?
Oh, right.
So stack CK, right? So
Hey.
you got to you're gonna have to populate it. You're not gonna automatically have this list filled with CB34, right?
Yeah.
Keep going. Yeah, go ahead.
That makes sense.
Yeah, with that being said, I
I
think
have
you
another
can still go.
Alright, so my second idea of how this could work is like, first, I have C, then after that, ended with B, and then after that, 3. Now it detects 3, and then it pop,
Okay.
and
Okay.
then pop.
Okay. Yeah. Okay. Yes.
then-
Yes.
And then after that, what is it? Then I could delete those.
Yeah.
And then append with, what is it, 4?
Yes.
And then I'd pop that again.
Yeah.
And then, yeah, pop.
Pop.
And then I have.
Nice.
And then I'm left with.
Is this guy a
like
genius?
it said-
Dude, I'm telling you,
This
bro.
guy's a
This guy, bro, he
genius.
surprised me, bro. He's
This guy is
surprising
a
me.
genius.
He got it. He got
No,
it.
come on, bro, come on.
Bro,
That is
he's crazy.
crazy.
Man. He's crazy.
Okay.
Just,
I mean, that
just-
looks pretty good to me, but
Is that
go,
right?
Jose. Go, Jose.
You're right. You're right. You have the right thought, but you're doing an extra step though. An extra step. Like
Okay.
you're on it. Like you're a genius, bro. When it comes to, but you're doing it in a little extra step, right? But I think like you have the right mindset. Like you have everything.
How
There's a
about don't
little
tell him the extra step?
Yeah. You're doing a little extra step that you can, save. That's a little bit. You can still do it and it works, but it's a little bit unnecessary. You're on the right track. You're on the right track, my guy. And like Carlos said, bro, you're a genius, man. You're a genius.
I think
All right.
that's pretty solid.
Okay.
And honestly,
Yeah,
I
it
don't
is
know what
pretty
extra
solid.
step Jose's talking about right now, but I want to see you now translate it into code,
Yeah.
And
Let's
then-
translate into code.
and then we could figure out that extra step probably there. We'll probably recognize
yeah.
where that extra step needs to come in. So you feel
Okay.
confident? You're good here with the visuals?
I feel confident now. Yeah, like after drawing it out. That
Yeah?
Yeah.
helped.
Damn,
Okay.
bro. I'm excited, bro.
I'm excited, all right.
Good.
Now we're going
Man,
back.
Bro, he just came in here. He's
Yeah.
like, bro, hold my beer. I'ma take this on, bro. Damn. Damn.
And
Yeah.
we could come back to the drawing if we need to. So let's go back.
Yeah.
We're back here on the problem.
Okay.
Clear digits. For anyone who's just joining, we're currently introducing Simon, the freshman, to stacks. We just gave him a rundown on the drawing board, what stacks are. He literally right now just showed us how to solve this problem using stacks. And now we're going to see if he could translate it into code. If he can't, that's okay. He's new to it. We're here to help him out. Simon, are you ready?
I'm ready.
All right, go
Okay.
Simon. What are you
And
thinking?
when it comes to syntax, bro, just let us know and we'll take care. We'll help you out with the syntax.
Okay.
Yeah.
So yeah, I would honestly suggest, Simon, before you start coding, you should maybe comment your step, your plan.
Okay.
So, or shoot, maybe you could just do it right now, or don't have to do any comments. But that's what I would suggest. Just like write it out and then do your code.
Okay.
So what are you thinking?
So right now I'm thinking I have to figure out a way. It says on the left like input is s equals abc.
Mm-hmm.
Huh?
Now, how am I gonna get that input? Am I gonna use something like input?
Oh, you have it
Or-
already over here. Called S.
Oh.
You just use it. Yeah.
Okay.
It's like
okay.
a small
I just
parameter
use it
you
as
have.
that.
Yeah. Just use this.
Okay.
Yeah.
Okay, so I feel first I have to figure out how to append s onto the stack.
Okay.
So I can say maybe stack or is it dq dot append? Or no, it's stack dot append.
Yes.
Stack
Okay.
Just like that. So stack dot append.
So right here, what are you trying to do? You're trying to add something.
Yeah, so okay, sorry. Right now I'm trying to add the first index of s.
Okay.
So I forgot exactly how to do that in Python. I think it's s0.
Well, quick little comment outside. We got 6 likes and 6 people watching now. People, thank you guys for tuning in. Make sure to drop a comment below so we can give you a shout out. And while you're dropping a comment, please leave a like. And hopefully you guys are enjoying the show. Let us know how we doing. Thank you guys. Sorry, Simon, for interrupting you.
No, it's good.
So right here, you're basically looking to iterate through S and add to stack.
Yes.
Okay.
Yes, yeah, this is pretty good.
So
Okay. Yeah. Continue. Sorry.
So now I've got it. I can append all the values of ABC to the stack. Stack. Now I think oh okay, I see. I think what I need to do is on every iteration of that I need to check if what is it? Maybe if s of I.
This
or
guy's
s
cheating,
index
man.
I. Dude, I'm not cheating. I'm not cheating, bro.
No.
I'm just smart.
That's it.
Come on,
We're gonna kick you out. We're gonna kick you out, Simon. You're way too good.
Dude, you can't kick me out.
Okay, keep
Yo,
going.
bro,
Sorry.
you-
I
Might
just
have
have
to
to
give
say
me
that.
something medium next time.
No, the next one's medium. You're doing that one by yourself, dude. We're not helping you at all.
Really?
And if you don't know how to do it, oh well, you're gonna drown. Sorry,
Alright.
Simon. You're doing great. Keep going.
Okay. If s of I type, can I do like?
What are you
type-
trying to do right
it's,
here?
It's you try and check if it's an integer, right?
Yes.
Okay. Yes. So there's this thing called if I'm gonna go in here. It's called is digit. Pretty much returns
Oh.
true or false if it's a digit. Turns true if it's not. Turns false. So yeah, there's a little bit of syntax up there. Yeah.
Okay. Makes sense.
This is
So, if that is true, if it is a digit, then I need to pop twice.
Okay. Yeah.
So stack dot pop. That's funny.
Why is that
Stack
funny?
dot pop. I mean,
What's funny?
it's not that funny.
This is a game to you, Simon.
Damn, bro.
No, I mean this is
Damn,
serious
bro.
business, man.
All right.
Serious business. All right. Stack dot pop. So then now this should, yeah, I can write it out here. It should, like for CB34, say, for C, it's gonna append C, and if it's a digit, it's not a digit. Then B is not a digit. Then 3 is a digit, so then it's gonna delete these.
Damn, bro.
Then
Okay.
4, and then delete those. So it should
Damn,
be.
okay.
So after that whole thing is finished, it should return stack.
Okay. Okay.
Let
Perfect.
him let him figure it out,
Uh-huh.
Jose.
Yeah.
All right. So do you want to do any of your own test cases? Do you want to like try out any other test cases other than the examples, Mr. Simon?
Yeah, I think so.
What test case are
Because
you
I just
thinking?
remembered. I just remembered actually. The operation cannot be performed on a digit that does not have any non-digit character left.
Mm.
So I need to put right here,
Okay.
like, and so now I need to check like if the digit before it is, or no, not the digit, if the index before the digit is a character, right? Or maybe if it, I think
would.
character, I think, right?
Yeah. The only tip I would say is to read the last bullet point on the constraints and see how you can connect it with the node. Yeah.
So S consists of only lowercase English letters and digits. Okay. The input is generated such that it is possible to delete all digits.
Yes.
Okay.
Yeah. So in the node.
Oh no, we lost Jose.
Oh, really?
All right, it's just me and you for now until Jose comes back.
Okay.
So, honestly, I don't know where Jose was getting with that. It's just saying like you can delete all digits. But yes, that is a problem. You need to figure out, like for the example, which one was it? It was like, let's imagine CD345. You end up doing all of this, right? And then now you're just left at 5, and you go to 5, and now you're like, okay, let me pop again, but there's nothing there, right? So that's where you kind of got to think, what extra condition should I do to make sure, like,
Yeah.
So what do you think?
I think
We got a comment
yeah.
from Daily. Yo, bro, I'm also a JS developer. Can I get your Twitter handle? Shall we connect there? Hey, we have hey Daily, by the way. We have our LinkedIn's in the description if you want to add us. Simon, you have a LinkedIn, man?
I do.
Okay, I should have put it in the description. I'm sorry. If you don't, you can send it to me and I'll add it to the description later. But
All right.
So okay, so take me through your thought process right here.
So like here I'm thinking like if for the current iteration that we're going through, if that current what is it? Like if that current index is a digit and the index before it is a character, then I can pop both of those. But if only it's a digit and there's not a character before it, like something like this right here, if I like delete these two, then I delete these two, and delete these two, and then this one because it doesn't have a character before it, I won't delete it, so I'll just be left with 5.
Mm-hmm.
So, in my
Can
mind,
you guys hear it?
We just got
he's
word. We
back.
got Jose on the line. Jose,
The bad bro. I'm joined in from my phone. Joined in from
Okay.
my phone.
perfect.
I know.
I'm here.
All right, Jose, do you want to continue on that thought? I think Simon's on the right track.
Yes. Yeah. Let me see what thought it was. Oh, it was on the digits, right? Okay. So on the constraints, it says that all digits are supposed to be like they are have to be removed, right? It's like that's one of the constraints that the input is generated such that it is possible to delete all digits. So that means that each digit has a corresponding letter. You know what I'm saying?
Yeah.
Like,
yeah.
Yeah. And the note is saying that pretty much like in order to delete a digit, it has to have a letter beside it. So for example, A5, AB3, you delete those, right? And C4 at the end, you delete those. So I don't think there's gonna be a case where you're just gonna be left with just a single integer, if that makes sense. Because you're gonna be able to delete all digits.
I see what you're saying. So
Yeah,
it's either
it's just more like
so this note right here is saying if there's no digits at all, this like you can't perform the operation.
yeah. Or in the case, for example, in example 2, if you start at 4, you can delete 4 because the previous digit is 3, right? Which is right, it's not a string or it's not a letter, it's a digit, right? So you have to start at 3. You know what I'm saying? And because
Yeah.
3 has a non-digit character, which is B. So you can delete those, but eventually 4 is gonna end up with paired up with a non-digit character, which is C, which you will be able to delete. I'm not sure if I'm making sense.
I think I understand
But
you, but
that's how-
honestly, the way I interpreted Jose, and also we got a comment. I'm gonna read it right now. The way I interpreted it is saying like that it is possible to delete all digits, but maybe there is a possibility not to delete all digits. But you know what? To figure out if that's the case or not, how about we just add a test case, Simon? How about let's just add that test case and run it and see what it tells us. It will tell us if a test case is valid or not. So let's do AC A345 whatever, right? I'm gonna run it on my
guys.
end.
My internet just came back, so I'm gonna switch back to my desktop. I'll be back.
Perfect. I'm gonna run this and then see what it says.
Oh, the test case?
Yeah.
I've never done this before.
Okay. I know what you're doing, what you meant by this. So, Ufas. We might need to delete this real quick. Let me delete this.
Hello.
Hey.
Am I here? Yes.
Yes.
The back.
One second.
He's back.
Ignore Simon. Don't look what I'm doing, okay?
Okay, I'll look away.
Just return. I'm not even gonna return nothing. I literally just want to see if the test case is valid. Okay, test case is valid. So that's all we need to know.
Test case is valid. Okay.
Okay.
All right. That's okay.
So that's all we wanted to know. So I think Jose, I think what you're saying might be true or might not be, but going based on it allowing us to do that test case, there will be a test case that will involve one digit being remaining. That can involve it.
Interesting.
If I'm understanding it correctly, but let's
Okay, we'll see.
let's ignore that for now, Simon. Let's focus back on how are you going to do that? Like if there's one, how will you do that? And you're on the right track. There's multiple ways to do it, but you basically you want to look ahead again. So you're at the stack. You pop 3, right? And now you want to look at B, or sorry, let me do this example. A, B, C, A, B, 3, 4, 5. Okay. You pop 3, right? And then boom, it's a digit. You pop B. These are gone, right, Simon?
Yeah.
You keep going. This is your current stack. You keep going. You go to 4. Boom. You look. That's a digit. Now you do double pop. You pop A. Going based on your logic, minusing this right here at the end, this new one. Now you go again. You find the digit. Now you double pop. That's gonna return an error because there's nothing. You can't double pop. So. Yeah. How can you say, like, how can you ensure you pop both? How can you basically go, Jose?
Or you append certain values to the stack. Not all of them, just certain values. Here's where the extra step I was talking about.
Okay.
Yeah, because
I think so. Are you saying that you're gonna go through the list and only append? So you won't append the values first. You're gonna like search through the list and then decide what values to append to the list at the end. Am I getting that?
A little bit, because like Carlos was saying, this double pop will give you like an error, right? But what if you only append the non-digit, like the letters, like the A and the B, or the C and B in example 2? Not sure if I'm making any sense, or I'm like throwing curveballs. I don't know.
I see what you're saying. I'm just trying to find.
Okay.
I know that you guys see like a flaw in the logic of my code, and I'm trying to find what that flaw is because, like I won't run into that runtime error that pops up because it will also like it checks if I have a what is it, a digit here
I
and
see.
a character here. So there's going to be 2 characters in the first place. So it'll remove those 2 characters.
Okay, I see. Okay, that makes sense. So pretty much your statement saying like if it's digit and then it checks the I-1, right? And then it checks if that's a character. But like Carlos was saying, there's an like what if you're just left with a 5? Because then you won't have a character to go back in the list. You're gonna be like out of bounds, if that makes sense.
Well, is it illegal to have just a 5 left over? Because it does say return the resulting string after removing all digits.
Well,
but I feel like in some cases maybe I can't remove all digits, or maybe it won't give me those cases.
Yeah. Let us see. It's because that's the thing. Because if you need to remove all the digits, you need to have a non-digit character for it. If that makes sense.
Yeah.
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 So.
Because
Where-
maybe it won't give
Huh?
me any cases. Maybe it won't give me any cases where there are more integers than characters. So I'll never run into that problem.
Probably, yeah, probably. Yeah, I think that's a good assumption to make.
I have an idea if y'all are a little stuck.
Yeah, for sure. Yeah.
Let's go back to Excalibur. And let me show you a little possible solution. Is that okay, Simon?
Yeah.
Okay. Let's switch back to there. So, Jose, are you still here or you're frozen?
Yeah, I'm here.
Okay. Make sure you get the ninja set up again.
Yeah, I sent it over already.
Okay. Let me do that real quick.
Yes.
So I'm gonna just
And
show
Simon,
you a quick
yeah.
little thing, and also Simon, this is not. That's okay to get stuck. Like where you're at
Yeah.
right now, that's totally fine. So don't be worried that it's not perfect right now.
Yeah.
Okay. So let's use the example where we have an extra letter, right? Simon, do the honors. How would you, based on your current code, how would it look visually? And yeah, how would it look visually?
Okay. Let me zoom in a little bit. Well, first, what is the example? ACB34. Okay. Well, first it would append or push the A.
Okay.
And
then what is it doing once it? Why did it push? Sorry, go.
Whenever it pushes A, it's also gonna check, you know, if that's a number, and a character.
Okay. Perfect.
Okay. Next, it's gonna append C. That's a bad C. And it's gonna do the same thing. It's gonna check. Then next, it's going to append B, and again, it's gonna check if it's a number. It's not. Next, it's going to append 3, and 3 is a number, so this is true. And B is a character because it's the one at the index I, which is this index minus 1. It's going to be here. So this is also true.
Perfect.
So then it would delete these. And then at this point, we're past the 3. So now it's just 4. So then it'll append 4. And then it'll check, is this a number? Yes. Is this a character? Yes. So then it'll delete these. And then I'm left with A.
I'm so dumb. I gave an example. Okay, yeah, you did it right.
Yeah.
I gave an example that freaking leaves like that. Okay, then you just did the same thing, right? Blah 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 blah. You did B3. Wait, go back. Revert that.
Oh.
You did what? Basically, what you did B3. Boom, they're out. You did 4C. Boom, they're out. Now you're left with 5. Okay, that's kind of what I meant to do. Now you're left with 5 cents.
Okay. Yeah.
Okay, you added. You based on your logic, right? You iterated to 5. You're right here, and then you're saying, is it a digit? You haven't added it to the stack yet because this condition is first. You have this condition before you. Wait, no. You add it to the stack. Yeah, sorry. You do have it to the stack.
Yeah.
Then you to figure out if you want to pop it though, you have this condition, and then if right now though, let's minus the char. Right? Let's minus this.
Okay.
You're saying if num, if it's just num, pop both of them. So you want to figure out, and that's an issue because there's not going to be nothing else to pop, right? You recognize that. You want to figure out how can you look back down to the next one ahead of time before you do that pop. The thing with stacks, they're not index based. Okay, that's another tip for you. There's no index, so you can't say I minus 1.
Oh.
Right? Unless you were using the list, the original list over here, right? But we're using a DQ, so DQ there's no I. Okay, makes sense.
I see.
But
I realized where I went wrong now. Yeah.
But that's just like the tip of the iceberg. I think for a suggestion, using the DQ, right? Using the DQ is that you potentially store the pop, right? So you say let me visualize it again. Let me go back to your code. Go back to your code, please. So you would say a, or like val1 equals stack.pop, right? This is gonna be the digit. So we're gonna say is digit boom, val equals that. You're not gonna do the second pop though. You're just gonna say, is it a digit? Boom, pop it. Now you want to say if there's something in the stack and it's not a digit, pop it as well. If it is a digit, then you basically just append this val1 again to the stack, or you append it in the beginning. Does that make sense? Let me visually show it. Going back to this right here. So following that path, right? You want to say, okay, is this a number? Is 5 a number? It is, right? So now you store it into a val equals 5, right? Then again, you say, now you have this. Now after that, you say, if stack isn't empty, if it's not empty, check the value in it. And if it's not a digit, boom, you're going to pop that one too. If it is empty, then boom, you're just going to add. You're just going to append 5 back to it. So now you're left with this.
Okay. I see what you're saying.
Does that make sense? So it would work the same way if you have another digit like this, you have a 6, right? That's the same way. You initially pop the top, right? And then you say after that, is the stack empty? Right? So you pop the top. Is it empty? No, it's not. Okay, now is that a non-digit? Is that a letter? That's not a letter. So then you just literally add what you just popped back to the top.
Okay. I understand.
That's one way.
Yeah.
Jose, is there any cracks in that?
So, sorry, I wasn't able to pay that much attention because my internet and all that stuff is acting up and it's like kicking me out of the Discord and stuff.
Okay. That's okay, Jose. You could,
No, I think it's good though. I think it's good. I liked it. Yeah, I think it's good.
Perfect. Simon, what were your questions?
I don't have any questions. I just had a realization that I was treating it like a list. I was using, like, if I go back to LeetCode, like I was using what is it? The index of S whenever like I was updating the stack and not S. So like I would update the stack and then I would want to check if the stack like the stack's index -1 and I can't do that because if I check this the index of s minus 1, it could have been one of those values that I already deleted. So that's making sense to me now, because and I see the what is it, the method you're trying to implement. I can see it now.
Exactly.
Okay.
So if it's a digit, then I can pop it and store that value.
Mm-hmm.
And then what is it? Then if I do like stack dot is empty, if the stack has something in it, right?
Yes.
Oh, not. If the stack is not empty, then stack.pop. Now if the stack is empty, then then if the stack is empty, then I'm not going to add a value to it. Or wait, no. If the stack is empty, then I'm not going to pop a value to it, and I'm going to add back val1. So I can do stack.append val1.
Yeah.
I think. Okay.
That's basically it. There is another little issue, but I think we'll get to it whenever we sift out the issue, like whenever we run it, and then like we follow the troubleshooting. But you understand that, right?
Okay.
You understand how you would do that? Right? You understand why this implementation right here, like you pop it, store it, pop the next one. Is it if it's not empty, boom, you're gonna pop it again, right? Make sense? Okay.
That does.
So with that being said, let's just run the code and see what we get, okay? Don't click submit, but just click the play on your end. You can press play.
Okay.
Invalid test cases. What the heck?
Now it's invalid. Are you serious right now? Bro, there's no way. I ran it earlier. Jose, can you test? Oh, sorry. Oops. I changed it up. I changed it up a bit. Sorry. CB 3. Wait, no way. Oh my god. Alright, Simon, there was a whole big mess, bro. I'm sorry, Simon. I thought my test case earlier proved that interpretation could be wrong from Jose. Turns out I put the wrong test case. Like the test case itself didn't counter this right here. So I'm stupid. It's okay. That's okay.
I'll get. It happens. It happens. Don't worry.
Yeah. But I still think it's okay. Like it would still be okay, like the solution, but we didn't really have to do that. Anyways, what is it saying when you run it now?
Let's see. Run it. Okay,
also,
time error.
Jarquin in the chat. Hey guys, what's up? What's up? How you doing? Long time no see.
Long time no see.
For everyone that's just joining, we're currently allowing Simon to complete this problem. There's a couple hiccups, not like on our side as well. Jose disconnecting, me doing a dumb little mistake, but that's okay. We're learning here. Everyone's learning. The goal is to get Simon to complete a LeetCode problem for the first time ever. He's doing a great job. We might have got into a little rabbit hole right now, but now we're going back to the basics. We're focused and we're about to solve this damn problem. All right, Jarkman, what's up? What's up? We also got some comments in the chat saying I'm looking to master
Ooh.
data engineering, or I'm looking to become a data engineer. I'm looking to master some important concepts like data structures, array, linked list, blah blah blah. What would you best recommend for those concepts? Jose, what would you recommend for that, man? I put my
Okay,
input, but what would you recommend?
Yeah, for data engineering, Python. Python, 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 Python. For data science, data engineering, all that stuff. So Python is really good. And looking for mastering some important data structures like arrays, linked lists, queues, and stacks. Would it be the best path to mastering these topics? And I think I read your, yeah, and I do agree with Carlos. For sure. First learning Python syntax and then using LeetCode to reinforce, right? Learn how, exactly how Simon is doing right now. Learn how stacks work, the different functions it has, and then implement those into LeetCode. That way you can reinforce that knowledge a little bit better, 100%. And then we had another comment. Hi guys, I'm thinking about learning programming. Which language should I learn? I would say Python. Like Carlos said too, Python. It's a really good beginner language. Teaches you everything, has everything. Really nice, really simple to learn. Very beginner friendly for sure. Yeah.
All right, Simon.
All right.
What's going on here?
Oh. Also, I think I found a logic thing,
A logic
like
thing.
a logic hiccup. Like a little issue maybe. I don't know. It might be.
Do you think it's detriment? Like, do you think we gotta like change it up from the ground up again, or it's just a simple fix?
Well, a little bit I think, because if it's not a digit, and if I say like it's a, right, it's a non-digit character, we're still popping it out of the stack.
But we're adding it back.
Oh. Okay. Oh, I see. Interesting. Okay.
I think I see what you're saying, but this solution was under the assumption of that technical error I just made, which was the test case. I put the wrong test case, but I still think it works. Like you just might need a little bit of fixing though. Simon, so you get the runtime error. You got string indices must be integers, not str, right? Is that what you're trying to figure out?
Yeah, so it's saying that the indices, like the index, which is I right here, that must be an integer. So maybe that means that it's not an integer right now.
Yeah.
Maybe that means that I is equal to A or B.
Perfect.
3, 4, 5.
Yeah, that's exactly what it's saying.
Okay, so I need to implement a counter then.
Not necessarily, Simon. I think it's just a simple fix. Since you're saying for I and S, it's gonna say, like you just said, it's gonna go A, it's gonna go B, it's gonna go 3, it's gonna go 4, it's gonna go 5. Right here on line 10, which is saying on the error, line 10, it's saying indices must be integers, not str. Since I is a str, right? It's gonna be A. You're saying S at A.
Yeah.
Right? You don't need to get the index of S. All you need to do is just put the letter, which is I. Does that make sense?
Oh yeah.
Yeah.
Yeah, that makes sense. Okay, so I don't even have to worry about indices at all in this problem.
Yeah, so
okay.
so I is the current letter, basically. The current letter that it's on.
Yeah.
In this for loop.
Okay.
Yeah. So here again, you would say if I is digit, then
yeah, if I is a digit.
wait, if
Or,
if s dot I is si, you appended it to the stack. You already appended it. Then you pop it. Yep. Okay. Yeah. You're looking good. So right now, if you're looking at this example, AB345, which I don't think it's valid anymore, right? Did we confirm that?
Yeah.
Okay,
Yeah.
so ignore that. There will never be an extra digit at the end. We confirm that, okay? So now, right now, you're saying A is in the stack. If A is a digit, pop it, okay? A is not a digit. Boom. And then, then you keep going. If it's not empty, then you append it back. Oh, man, dude. Oh. Mr. Simon, I feel like I let you down, bro. I'm gonna be honest.
Nah.
I feel like I let you
happened?
down. There's just like
What happened?
you're on the right track, but obviously you're gonna hit a big hiccup, and then my whole theory that I was leading you on was totally wrong. So that the past like 20 minutes with Jose like leaving with his internet and then me trying to fix what Jose was saying, like it was totally incorrect,
Yeah.
right?
Hey, we can still save it though.
But
we can
it's
still save
savable. It's savable.
it. Savable.
It's savable, and thankfully
Yeah.
you're using a DQ. You just gotta do some different little functions sometimes. But anyways, all right.
What, so you're saying like the whole thing where we had an extra digit at the end?
Yeah.
It'd be like
Yeah. There's never gonna be an extra
Like-
digit.
never gonna
Yeah.
happen.
So,
Well, this still works in that case then.
it could still work,
Still works,
but there's some things that I don't think we taught you that you might need to do, and that's kind of why I just said I kind of led you in the wrong direction. But if we could still trace it, and if you could recognize it, I think you could fix it. So as long as we're tracing this example and you could see where it kind of goes wrong, we could quickly fix it. So,
Okay.
I'll allow you to trace it then.
Okay.
So, where were we at?
I'll start with.
Yeah.
I'll start with AB34.
Mm-hmm.
Same example. Okay. For I in F. For I in stack. Oh no, in F. In F. Okay. So it's gonna go. It's going to append A. Then it's going to, or it's gonna append I, which is. Here, I'll just write out. I equals A for the first one.
Okay.
So I equals A. It's going to, it's going to append A to the stack. Then it's going to check if it's a digit. It's not. Check if stack is empty. Stack is not empty. If the stack has something in it, then we're going to append val1, but we don't have val1. So I think that's the hiccup you're talking about, because then we're gonna run into an error because we don't have, or val1 was never initialized, if I'm not mistaken.
Not stack is empty.
Yeah. And also,
I think it's this right here. I think maybe it was confusing. If it's not empty, which means it's full, it'll do this. It'll do this one right here.
Oh, I read that wrong. Wait.
yeah.
Okay, yeah. Because if the stack is not empty, then it's gonna pop. Okay, so then we're back to, okay, scratch that error. Then now we're back to nothing.
and
Yeah.
that's
So
the
then I'm
error.
just going. Yeah, so then I'm just gonna go B and then nothing, and then 3, and then nothing, and then 3, and then go 4, and then. Oh wait, why don't? Yeah, and then nothing, and then nothing, because the stack is not empty.
So
then
I
we're just
literally,
left with
honestly, I literally think your initial solution was correct.
Really?
I honestly
I
think
think
it
so
was.
too. I think so too. Yeah, we can go
Okay.
back though. We can go back though. We can
Yeah.
go back.
Okay.
Yeah.
I think
so
it's
I
literally
was-
just right here.
Yeah. Yeah.
Boom. That's literally where you're at.
Yeah.
Okay. Yeah, so then it's
Then in the stack that pop.
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 And
Yeah.
but here I can't I still don't think my initial solution was correct because I was relying on s of I minus 1, and I can't rely on that. I have to rely on
I mean, if all the, if let's see, Mm, so if all the digits are right, digits are like you can remove all digits, right? And the condition is that each digit is followed, right, or pre-followed by a non-digit, right? I don't think you have to check if it's like the previous value, it's a non-digit. Because we know for
Oh, you don't-
sure.
okay.
Yeah.
You don't think I
Because
have
we
to
know.
even check for that at all?
Yeah. Yeah. Because either way, they're all going to be deleted, and to be deleted, they'll have to be followed by a non-digit. So you kind of, for sure, you can kind of, you know. Yeah, you don't have to check for if it's digits or not.
Because
Okay.
if there's a digit in the string, it's going to be removed. There's not going to be a case where there's going to be a digit remaining.
Yeah, pretty
Okay.
much. Yes.
Yeah.
Yeah.
Makes sense. Makes sense.
So I think
Okay,
that's
so
it.
then
And I think there's one little thing, but you'll figure it out right now. And we'll tell you how to do it.
Yeah.
So you wanna
So
run
let's
it?
return the stack. Let's see, can you? Yeah. Let's see. Let's see if what happens.
Run it?
alright,
Alright.
let's see. Oh, okay, we have a runtime error. DQ ABC is not valid value for the expected return type string. Oh, okay, so we have
Oh,
to.
we return a string. Okay.
Okay.
So, that's a syntax error, syntax issue. So I think we can just jump in here. On Python, you can turn a list into string by using the join function, which pretty much you go dot join like this. So just a little bit of context. Join is gonna join the values inside the list, right? And it's gonna use this thing, right, or this value that you put in the top in the front, right, as the, let's call it as a separator. For example, if we had stack 1 2 3, right, and we put comma dot join stack, our string is going to be 1 comma 2 comma 3. If we put a period, right, it's going to replace the commas by the period and stuff, right? So it's just gonna, is a way, like it's like the glue that's gonna stick all the elements per se. But if
Yeah.
we leave it empty, right, we're just gonna have nothing in between the elements. So it's just like a separator, so we can like separate the elements from each other, right? But we can leave it, if we leave it empty, it's just gonna glue them all together and return all the values as a string. So that's the join operator. and yeah, so which are pretty, it's pretty awesome. If you ever run into problems, it pretty much like turns all the lists into a string, which is great. Yes.
Yeah. Okay.
Yeah. Yeah. So let's see if you
Seems like
run it and that
it'll work
works.
then.
What?
Run it.
This seems like it'll work.
Oh,
Running
yes,
it.
yes. Hopefully.
Alright.
Oh,
Accept.
oh, nice,
Perfect.
nice. All right.
Okay.
Check the discussions though. Check the discussion. If you go to the description and go all the way down, Simon, there's a discussion, little tab, and sometimes
Oh. Yeah.
some people put test cases, and I saw that there's a test case, and you can copy it, right? Once you copy it, you can go to test cases, I think. Yeah, on the tab of test cases tab, and you can copy them and put them in there.
Okay.
Yeah.
Yeah, I'll do a couple.
Yeah, and see if that works.
Alright, I'll try it again. Okay.
Hey, let's go.
All right.
Okay.
Did you click submit? We click submit now. That's the final say.
Submit.
Ready? Clicking
Submit.
it.
Let's
I'm
do
clicking it.
I'm clicking it.
Let's go, man.
Hey,
it up for
let's go.
Clap it up for
Got it.
Simon.
Let's go, man.
Let's go, man. Dude.
That is crazy, bro.
Yeah. You
Let's
basically did it minus the 30 minutes that I led you on. You did it. You basically solved
Yeah.
it.
He did it, bro. He did it, bro. Damn.
Nice,
Okay.
Simon.
Good.
Good stuff.
Alright.
Nice.
Thank
Yeah.
you.
Now what?
Thank-
No, I'm joking. All right. Well, what do you think, Simon? Can you? What are your insights? What did you learn from this problem? I think we still got time left. We'll see if we can maybe get the other one. If not, we're gonna verbally explain, or we're gonna see a thought process on the next problem. But what do you think?
Yeah. Well, it makes sense. It makes sense. I definitely learned that, you know, when you're dealing with stacks, you can't really like, what is it? Refer back to that initial. Like I kept trying to refer back to that initial string that was S.
Yeah.
And I was editing the stack while referring to the string, and I was expecting a value from the string that like to be updated, just like like I was updating the stack, but I just can't do that. That's not how that works.
Yeah.
Yeah.
So I mean, I definitely learned that, and I mean, I definitely learned how to, you know, interact with stacks throughout this whole thing. But yeah, I mean, it was not as difficult as I was thinking it would be. I thought it'd be more intimidating, but it definitely like running into problems and figuring out why those problems happened. I don't know. Excalibur definitely helps to like visualize all that. So
For sure. Should we have him explain this problem solution?
Pass. Not sure. Should
Or
we,
did
or
he
should we
already do
just
it?
like?
Jump to the next
think
one,
he
see
did
if you
it
could
already.
quickly get it.
I'm
20
not.
minutes?
20 minutes. Not sure,
He's
but
down
yeah,
on
we
you,
can jump in
Simon.
and.
oh, we can do it.
As-
We can do it.
But like in
Alright.
20 minutes, I'm not sure.
He's
But I
down
think
on
he
you,
can do
Simon.
it, but I'm not sure.
Next.
Not sure if we can do it.
We got
20
it.
minutes.
All right, Simon. We're gonna try to speed run
Alright.
this one. Use everything you've learned. Everything you learned from the last problem, minus the
Okay.
whatever I was leading you on to. Everyone that's here, we stream every Wednesday, or we post videos every Wednesday. Thank y'all for chatting it up. Caleb, what's up, Caleb? Put the goat emoji. Melanie Cruz
Yo,
clapping
what's
it up.
Caleb?
We got Sleepy Dev, Division. Ooh, I don't know what Sleepy Dev means by that, but yeah, Division, man,
I
it's
don't know.
crazy.
Yeah, I don't know.
Okay, with
Nah,
that
man,
being
we got
said,
Ali.
Ali. Oh, sorry, Ali. I skipped
Yeah,
over
we.
you.
Yeah, Ali's kind of like that. Finally, bro. I think that's she's starting some hate, bro.
That is
Starting
some
some
like
hate in
hateful
there.
stuff. We don't
Yeah, some
condone
hate.
like hate or of any kind. So
Yeah,
Ali, we might
yeah.
have to kick you out for tonight.
Yeah,
I
kind of
appreciate the
ban
claps
you.
though.
Yeah.
Hey, bet.
If you're new here, we do this every week, where we do LeetCode. It could be a video, it could be a stream. Like it up, please. Anyways, all right, speedrun this one. Read it up, do your thing. Go ahead.
Right.
Damn.
Do it.
Put on post noties. Post noties on. Raise your hand if you got post noties on. All right, go.
Could you actually send me the link?
Oh.
Oh, yes.
Sorry.
Damn. Bro, this guy's rushing you to start, bro.
Sorry.
Let's go.
And this. All right. All right. Go ahead. Whenever you're ready.
All right. Okay. Do it. So valid parentheses. Given a string S containing just characters, parentheses, curly braces, and brackets, determine if the input string is valid. An input string is valid if open brackets may be closed by the same type of bracket. Open brackets may be closed in the correct order, or must be closed. Every closed bracket has a corresponding open bracket of the same type. Okay, so every one of them has a pair. Let's see. Example 1, open closed parentheses, that's true. It has parentheses of all three types, they all close, output is true. Example 3, parentheses and closing bracket, output is false, they don't match. These both open and both close, output is true. This opens, closes, opens, first one closes, then the second one closes. You can't do that. They have to be nested inside of each other. Okay. So s.length is in between 1 and 10 to the 4th. And s consists of parentheses of only that type. Okay. Okay. So I think we should hop into
Skeledraw.
so I can
Perfect.
draw.
I'm bringing in the problem.
All right.
We can move these. Oops, sorry. Move all this. Get that out of here. I'm gonna bring in the screenshot.
All right.
Boom. All right. All right, Simon. You know the
Okay.
drill.
So I'm going to be given. How do I write a text box? Okay. So I'm going to be given a string. Could be like.
I got you with an example, but
Oh, you got it. Okay.
yeah, I got you. Let me bring another example.
That'll help. Okay. Yeah. Perfect. Let's see. So first I have to check. Okay. I need to determine if I'm going to use a stack on this problem. Or not. So I'm trying to think. I could do something like I could check if this opens and like door like if the parentheses is opened, and I can like store that value equals true until it gets to this point, and then this is false.
Okay.
And I could kind of like, I could do the same thing for the brackets, and I can check like brackets must be closed before these can be closed, and if there's a conflict, then I report that, maybe. Not sure. Does that make sense?
Were you saying if you're gonna use a stack or not?
Yeah, I'm trying to think. I think I definitely do if I'm gonna use this structure, actually.
Yeah, I'm gonna
Yes.
just give you a hint. You're gonna use a stack. You gotta solve this using a stack. Actually, that's a requirement. I'm giving you a requirement.
Oh, okay.
Yeah.
Okay. Let's see then. So. Okay. Yeah. So let's say this is the stack over here.
Mm-hmm.
Let's say. Yeah, let me just like bring this example over. First example, or like first thing I put in the stack is this open parentheses. Next thing I put in the stack is the bracket, open bracket. Next thing I put in the stack is the close bracket. And then I delete those two. And then, oh wait, I just did the order like completely wrong. Okay. Next thing in the stack is this, and then I delete those two. And then, you know, next thing is this, and this. And I delete those. And then, you know, same. I can never draw those. Okay.
Yeah, no worries, I good.
Just do some squiggly.
Alright, yeah. And then that's closing. Okay, well.
Don't worry. I think we could do some reverse action. Can you? Is that possible? Hold up. Boom. Oh. Wait. Yeah, then do this one. Boom.
Boom.
Alright.
Okay. Yeah, so then I reverse those. Now, if I take something more complicated, like example 3, then I'll have this, then so opening, and then closing. So then I will delete those, and then I'll have closing, and then I'll delete all of those. Now I need to figure out how to transfer that logic into code, I think.
Do this one.
But actually, yeah, that's a good idea. I'll do this one. So if I do this, then opening again, then parentheses. Now this one and this one conflict. Or yeah, I'll just keep going. So now I have this. Actually, I'll revert that. So what is it? These two conflict. So it's just like it won't work that way.
Mm-hmm.
Because I have to check if the opening and closing brackets of the same type are next to each other.
Yeah. So then, what do you return if it's not? If you found a closing, right? Once you find a closing, you're checking the next one, right? If they're not in the same little family, then that you return false, right? Or what is it? What is it asking for?
Yeah, you return false.
Okay, you return a boolean. So seems like that's a pretty solid plan, don't you think?
Yeah, I think I need to. Okay, y'all are all
Sorry,
my,
just
my thing. No, it's fine. What is it?
what do you?
Yeah, I need to. So maybe I can initialize a stack like I did in the last problem and add to it, and then I can. Okay. I think maybe I should just start coding it.
All right.
Okay. Yeah, I was gonna say something. Oh, that I think I've noticed this on the last problem too. That you always append like the closing one, right? Or the closing parentheses. But I think for this problem specifically, not appending or not adding the closing parentheses to the stack and just having it like in the outside, right here, help you a lot. So you can see, so you can check, hey, right, I'm currently in this position, right? And it's a closing. Since it's closing, I can see like, okay, I have this parentheses. Let me peek at the top of the stack and see if this one matches the same family. If it matches the same family and it's a closing, right? So not adding the, so if it matches those two, it is correct and you continue on. But if it's not, like in this case, it is there, this is opening, this is closing, but they don't match in the same family. You only have to pop once, right? You don't have to pop twice, right? And having it outside is gonna help you see what's on the top of the stack. If you know what I'm saying?
Yeah.
Because if you have these, you have this one over here, and you say, hey, what's on the top of the stack or what's next, right? You can't really tell because you're just gonna see the same opening parentheses. So just a little tip for this specific problem, I would suggest not to put the opening ones or the closing parentheses or brackets onto the stack, because it's gonna help you a little bit with the solving of the problem.
Okay.
Yes.
Also, Jose mentioned an operation called peek. I don't believe we went over with you with that, but basically it's like what it implies, like you're not popping out.
Look at the top.
You're just looking at the top.
Yeah, you're just looking at the top. Yeah.
And there's usually a function called dot peek, right? But with DQ, I thought there was a function called dot peek, or you can make a function like that. But I searched it up right now in Python. All you have to do in order to peek, it's index. So
yeah, it's index.
So since your stack is a queue, or is a DQ, so you can say like stack equals DQ EU, right? In order to peek, you're gonna say STA, and you're gonna say -1.
-1, yeah.
Yeah, -1. And that basically looks... -1 just means you're looking at the end. If you're looking at it from left to right, like this, you're looking at the end. And if you look at this stack, like this is the left, the bottom's the left, the top is the right. Top is the right.
Yeah.
Like, you know, it's just vertically. Or it could be the other way. You could say the front in a DQ, you can actually add stuff to the front. So anyways, that's just more confusing. I used to get confused about that a lot, but I don't want to confuse you. So I'm just gonna,
No, that makes.
let's just imagine that, okay? All right, so we're good. You think you want to try to tackle it a little bit?
Yeah. Let's get some code down.
Okay.
All right. Let's see.
Okay.
You got this, my guy. You got this.
I got this. All right. Got stack equals DQ. So
Huh?
I think I need to start this off the same as last time. So for I in
Yeah.
F,
You're right. You're right.
what do I need to do? I need to check if it's a opening bracket.
Ooh. Okay. Yeah.
Because I don't. Number one, I don't know how to differentiate between the types of parentheses and brackets. And
Okay.
number two, I don't know how to check if it's open or closed. So maybe I can make a list of, you know, these are like the valid open parentheses. And
Okay.
then check if I is in that list.
Okay. Yeah. That would work.
How does
that
he
would work.
know that?
That would work. That would work. That would work.
Dude, I'm just
Oh.
I'm brainstorming, bro.
This guy, bro,
gotta-
he's.
Gotta think out loud.
I don't know, man.
No, this dude definitely
I'm
watched
cheating.
something. There's, I don't know.
Dude,
I don't believe
I
him.
didn't.
Did you watch one of her streams?
I watched the last one. I watched most of the last one with Mike.
With Mike.
Mr. Mike.
With Mr. Mike
Shout
Barreto.
out Mike. Shout out Mike. Anyways,
Shout out Mike.
keep going.
The substring problem. Yeah. Okay. So.
Okay. Yeah,
So,
I'd say continue with that thought. Yeah. It's a good thought.
So I can do like valid open parentheses equals a list of. This is gonna be hard to type out. Okay. Oh, I have to make a string of it.
Yeah.
All right.
Yeah.
And then
Interesting.
bracket.
Oh, I never thought about this. He's opening my mind right now. Okay. Okay.
And then valid close parentheses is
Oh. Okay.
okay.
Perfect.
Now, if I is if I is in valid open parentheses, then I'll append it to the stack.
Okay. Yeah.
So stack dot append I.
Okay.
Now, what is it? Else
Okay.
if,
Nice.
I in. Can I do in or just is in?
I think it's in. I think it's just in. I haven't seen the is in. Used.
I don't know what is.
Yeah, me neither. But we'll see if it works. If it works, we learn something new.
Yeah.
Okay.
If I is in valid close parentheses, so this is like whenever I get to that like kind of second stage of checking for the closed parentheses,
Okay.
I want to check if the last value is the same as the I, is the same type as I.
Okay.
But I haven't defined the different types of parentheses yet.
Yeah. Okay. You're doing great. This thing is really nice. Yeah, I would say that. And here I would say,
Not the right direction.
not quite. Yeah, I would say it wouldn't be the right direction.
Okay.
Determining, yeah, because if you say I is invalid close parentheses, doesn't really give you, right, that much information of what type of close parentheses is. You know what I'm saying? You just
Yeah.
know it's like a valid. You don't know if it's like parentheses, a square bracket, or squiggly line.
Mhm.
So, so yeah, I think this else if statement could be a little bit better.
Okay.
Yeah.
So remember, Simon,
Uh,
if you find an open parentheses, you're adding it, right? If you find that it's open. If it's not, if this isn't valid, what's the only other option you found? If it's not an open parentheses, what else will it be?
it's obvious. It has to be a closed
It's
parenthesis.
gonna be a closed, right? So
Okay,
you don't.
so I don't need
Yeah, you don't need an elif, but you will
Yeah.
need an else condition, and in there, that's where you have the logic where you said, okay, you found a close. Now you want to see if it matches with the stack, with if there's something in the stack, right?
Yeah. Yeah.
So now you want to check the stack. Is there something in the stack? Great, there's something in there. Okay, now, is it an open parentheses? Yes, it is open. Okay, now does it match my closed parentheses that I found? Oh, it doesn't
Yeah.
match. Okay,
Okay.
return false. Oh wait, it does match. Perfect. Keep going. You pop both of them out.
Yeah.
Yeah.
Okay,
You're right. You're right.
I can imagine if I is equal. Oh no. If I is equal to the open bracket, then wait, is this right?
You already checked if that I is a valid open parentheses. Right now, if you got here, I is a closed
Closed.
parentheses. Yeah, so right now I is closed parentheses. So
Okay.
what
Okay.
can you-
Wait, I have
yeah.
it. I have it. I
Okay,
need a
okay,
peek.
okay.
I need a peek.
Okay, yeah.
I need a peek. Stack dot peek
Okay,
equal to open braces.
okay.
If I equal. Oh wait. Yeah. If I is
Mhm.
equal to this one right
Uh-huh.
here. Then I need to do what I need to do. I need to remove both of them.
Yes.
I think.
Well, okay. Okay. You said you want to remove both of them, but you only
I appended one of them.
Yeah.
you only
Perfect,
appended one of them.
perfect.
Yeah, there we go. Perfect, nice.
So that means
Uh-huh.
Beautiful,
Nice,
beautiful.
nice, perfect, beautiful.
Alright, now I just need to copy that like 3 times.
Yeah,
Alright.
pretty much. Yeah.
Yeah, I'll just copy paste.
Nice. Okay.
there's gonna be
One
something
thing
wrong
that-
here.
Yeah.
Okay,
There's-
wait,
Well,
yeah,
I
tell
will,
him if
we'll
he
talk
sees
about
it.
it once. Yeah.
Oh,
Well, I'll give you an example right now.
oh, I see what you're saying. I see what you're saying.
What is it? What is
Let's
it?
see if I can.
Oh,
I'll give you this
I get it.
example with
break. I
Almost.
need a break.
Wait, is it?
Right?
Not
No,
quite. Not
no,
quite.
no, no. Almost. Literally the opposite.
Oh, continue.
Yeah. And then also
Right.
you gotta fix some other stuff. Am I right? Yeah, cause
Yeah,
he
we can
needs
do
to.
that. Yeah.
Cause if you would have not had continue, it would have kept going. It would have kept doing this. These.
Mhm.
Right?
And I just-
The other
Yeah.
option is an elif. You just use an else if all the way down. But continue is
Oh.
better. And then I think Jose's gonna mention something else. Right, Jose?
Yeah. Yes, I was gonna mention the size of the stack. I will let you trace this example put on line 4 and see if you. I want to see if you can catch it.
Okay.
Yeah.
All right.
Put this
So
stack in here. That way we can
okay.
kind of see a little bit better. But yeah.
Okay. So, for I and S, what is it? Okay. If I is invalid, open parentheses, which it is, then I'm going to add. Okay, that is frustrating.
Okay. Yeah. Let me.
Oh, let me move. Yeah, I don't know where mine's at. But,
Yeah, I'll just put it in.
Yeah. I just put it as a string. Yeah. No worries.
Okay.
move
Okay,
your cursor,
so-
Jose.
If I is invalid, open parentheses, which it is, then I'll add it. And then I'm done with the loop. Okay, then then I'm going to move on to the closing bracket. It is not in valid open parentheses, so it's going to be under else. Then okay,
Huh? You want else, and then
if
what do we?
this right here is this opening bracket, then if I is this closing bracket, then I'm gonna stack dot pop. I'm gonna remove this and continue to the next iteration. So then for I and S, if I is invalid, open parentheses, which it is not. And we're going to go to here, and it doesn't satisfy any of these permissions or conditions. So
What is?
then we return false.
You're almost there. You're missing it. You're right there. Literally right there. What is this doing?
Yeah.
That's
The stack.
checking if checking
Yeah.
if the last one is an opening
Yeah.
parentheses.
Well, we have an empty. What do we have in the stack right now?
At this time, we have nothing in the stack.
Ah, there it is. So if you're trying to see something in the stack,
Oh,
but we have nothing, is that gonna give us an
Okay.
error?
yeah, it is.
Yeah.
It
Okay.
Okay,
So,
so this is-
we gotta check for that.
Yeah. Okay, so else. So I need to put all that in like if stack dot is empty, and put all that in that if statement. That doesn't make
Or
What does it mean if it's empty right now and you're still on this end one? Like, what does that mean? There's this left, and it says, and the stack is
Well, that
currently
means-
empty.
What does that mean?
For the
Yeah.
problem's sake.
It means that it's false.
Perfect.
Yeah. Yeah. So if it's empty, we can assume that it is, you know, we don't have a pair for that specific.
Yeah. So then I can add a else, which is whatever variable is
Yeah.
false.
Yeah.
Right? Alright, and I don't need this first
Oh,
if statement.
well, if it's still empty, this thing is still gonna be running. So even though we have the else, like we return false, right? This peak is still gonna be trying to access an empty stack.
Oh,
Yeah.
yeah, you're right. Oh, yeah, so I didn't solve that problem. Okay.
You're there.
So you're there. You have the if statement there, my guy. Yeah.
So, okay.
So
I just need to indent all this. Alright.
Not quite.
Not quite.
One simple
It's just
solution.
One line.
If the
one
stack
line.
is empty, what do you need to say in it? In the if statement. What do you need to say right there?
Oh. If the stack is empty,
And you
Yeah,
know
I
this
already
is the
know.
only thing remaining.
okay, so whatever variable is false,
Yeah.
Yeah,
break.
that's it. I mean,
Yeah.
once you return false, that's it. Like, you don't need to break nothing. So yeah, you got it right.
Okay, I see.
You say return false. Is it F like this?
Yeah. Yeah.
And then
Yeah.
you could do that in the if statement, or you don't even need the else. But yeah, that works, I think. Right?
Actually, I don't think I'd even need this last else.
Maybe. Yeah, you probably don't.
Yeah. Yeah.
You're gonna have to
I don't
change
think
these
you need
again.
it.
Yeah.
Yeah. You're good there.
All right, and now
Nice.
what? Now
like
what?
So
How do you
now I
know
need
it's
to figure
true?
out how to return through. So whenever I get to the end of the loop, I need to figure out where the end of the loop is. Oh, it's just after the entire thing. So I think it should be this line.
Yeah.
Return true, because this return statement marks the end of the whole function.
Yeah.
Right? So then
I
this
think-
would mark the end of the function, and this would
Well-
never be reached.
Let me throw you another example. What if we have more opening brackets and parentheses than closing? Such that like something like this. Where we have 2 opening brackets and 1 closing bracket.
Okay. Well, let me trace it then.
Yeah.
Okay. So for I in S, if it's invalid open parentheses, I'm going to append this, same thing, and this, no issues there. Next step, it's gonna be I is gonna be this closing bracket, so it's gonna go to else, and then if stack is empty, stack is not empty. If stack is this opening bracket, and if I is this closing bracket, stack dot pop. So then I'm gonna be left with just one opening bracket, and then continue to the next loop. but that there is no loop. So then this is my final answer is,
Yeah.
This is what's left in the stack, and then it gets to this return true. But that is not true.
Yeah.
So, then I need to add out here. Is it if statement? So, if stack dot is empty. So if it's empty, then I need to return true.
Perfect.
And then else return false. Right?
Damn, bro. This guy, I don't know, bro. He lied to us.
Dude,
This
I
guy's
didn't
lying
lie.
to us, bro.
I
You're
didn't lie.
lying to us, bro. Ben is lying to us. Yeah,
Stop
but
it.
you're right. Yeah, that's the only edge case I would have thought about.
Is there any test cases in the discussion? I think that looks pretty good.
Let me see. Let me check that out. Let me see.
And also, I did not. Okay, keep going, Simon.
I was just gonna say we have 5 test cases.
Never trust what they give you, Simon. That's another known
No,
fact.
really?
Yeah, they would. You could pass all the default test cases, and then they're still gonna test you on 93 others that they don't show you, and then boom, you missed one.
Okay.
Yeah, that's
I don't think there's any.
I think we add that test case that you just did then,
Okay. Yeah.
because I don't think they have one
Let's
like
say-
that. So it's like this. You got
I
it.
just added it.
All right. Should we run it?
I'm down. Let's run
Run
it.
it.
Let's run it. I'll run it.
Oh, damn.
Oh, I think it's the is.
Oh, the is yeah. Yeah,
Okay. Run it.
Again.
Oh, it's empty. Okay. Oh, my eyes. I think it's
Lane?
empty. You can do if stack.
Oh, perfect.
Yeah. Yeah, you can kind of remove this, and like if stack is just gonna check if it's like if it has something in there, pretty much.
So then
Will
you
it?
have to reverse it, right?
Huh?
Will
Well,
it?
'cause
Or
if
does
stack is empty.
Yeah, if
then
stack
you
it.
have to do like if not stack, then, right?
Oh, yes. Yeah, my bad.
Good. Let's see.
Okay, run it.
All right,
So
let's
now I
run
think
it.
we run it.
Ooh.
Oh, wow.
Okay.
Do we feel
Okay.
good about this?
I
I'm
feel
gonna let you
good, man.
submit it. I don't want to risk our score because I know this problem's got some like little curveballs. Okay, Simon, you run it. If I
Oof,
see
I
that
know.
says it's accepted, I'm
Hard,
clicking
bro.
yay.
Harley's not trusting you, man.
No, it's not
Harley's
that I'm
not
not
putting
trusting you, man. I don't trust this
Believe
problem.
in it.
Are you gonna submit it, Simon?
You think I should?
Yes.
Oh, I'm submit. I said.
Oh.
Oh.
Spoiler.
Spoiler. Oh.
So Simon, did Simon submit it or no?
I didn't submit it. No.
I'll tag. Take my percentage.
Damn.
Oh, we were so close. 4 more test cases.
Okay, well, what's the
So,
test case?
When you submit it, so
Oh,
when you
let me
submit it,
send it.
it like decreases your percentage.
Yes.
What's going on with that?
Like you have a
Yeah, like the-
overall, you have an overall like acceptance percentage. Okay, this is a test case that we need to add.
Okay.
And also, I'm sorry, Jose. I did not realize we were already at time.
Good, man. Good. I was about to say something, but I was like, you know what? Let's see it, bro. Let's continue on. No worries.
All right.
Almost there.
What's the issue with this? When you run it, what does it say?
It's false. No, I'll put true. Ooh, why is it true? Let's trace it. Let me see. Okay, I see. Okay, we put that in there. Add square bracket goes here. Oh. Ooh.
I think.
Oh. I thought I lost you guys.
No,
A
no,
second
no.
there. Okay, wait. So
I
we
see.
first puts the parentheses, and then square bracket. Blah, blah, blah.
Wait, why does it bypass this right here?
I think I know maybe why. Oh, I think. Okay, so I think what's going on is that it adds the parentheses, right? It adds the parentheses to the stack, and then it goes to the square bracket. The square bracket goes to the else, doesn't meet any of the criteria, right? And then it goes to the closing parentheses that meets the first criteria. The first is the if statement. It pops it. Now we have an empty
that.
stack. Yeah, I
Simple
think that's
fix.
the problem.
It's a simple fix though, Simon.
Yeah.
And it's right. It's kind of right here on the second one. So just to give you a hint, it's saying, okay, you're in the else. You found the closing bracket, right? It's the square one. You're saying the stack isn't empty. We have this in it. We have this at the top. Okay. So now let's match it. Let's peek the stack. The stack has this, and then you go here. Okay, the opening is this, and now you do the if statement. Okay, if I is this closing one, well, it's not. It's actually this right here. Okay, so since it's not, there's no condition saying what's gonna happen if it's not. It's just saying if it is, then you're gonna do this, right? So you need to add a condition that says what will happen if it's not it to all of those.
Okay, so if it's not, then return false.
Perfect.
Yeah, pretty much.
And it doesn't match up. That makes sense.
Dude, I'm hungry. It's
Oh,
it's about to be 11.
Yeah.
I'm hungry. I'm hungry. Dude.
Hungry to finish this problem.
Yeah.
Alright.
Okay.
Uh,
Run it.
I'll
Submit
run
it. Someone take the damage.
Wait.
I'm waiting.
Syntax problems.
Where? Oh, that still works though.
Is it?
Yeah. For the
No
people
way.
that are joining, we got a freshman here, Simon. He just completed his first problem earlier. Now he's trying to complete a second one.
It works.
We stream every Wednesday or post videos every Wednesday. Please subscribe, put post noties. We're 5 away from 600 subs. All right, Simon, what's the verdict?
Run it. Submit it.
Accepted.
Submit it.
Accepted?
Should I
Hey.
submit it?
Submit it, dude.
submit it.
I'm gonna
Submit it.
submit it.
I submitted.
Let's go, Simon.
Accepted. Accepted. Got it.
Give it a clap. Clap up for Simon.
Alright.
Dude, Simon, man.
Congratulations, guy.
Wow, man. You really impressed us today, dude.
Dude, he's like, for it being his first time on the LeetCode, man knew how to do things. Man, I think if you do a little bit more, you're gonna be in a good place, my guy. Pretty good stuff, man. Pretty good stuff. Damn.
Really nice.
All right.
Simon, quickly, what did you learn from this problem? What was like a key takeaway?
From this problem,
Yeah.
what did I learn from this problem? That's a good question. I think I learned a lot. I learned how to peek. Uh, I learned like, I mean, I had some if statements that just kind of didn't have an else statement. Um, so you know, they kind of just like that was like where my problem was multiple times. You know.
Mm-hmm.
And then in the end here, like if not stack, was it like I really just needed to check for every little thing.
Yeah.
If that makes sense.
Yeah.
I don't know.
Yes.
And I mean, you did great tracing it. So I think if you do get an error, I mean, you can easily trace it and see kind of where that error was at. But no, dude, you did great, dude. Like this right here, I don't know how you initially thought of that. Like right off the bat, that's kind of psycho. That's very psycho, and obviously I was joking, saying like, you know, you might have done some problems. Obviously, I believe you that you didn't. So I think that's really impressive that you thought of that.
I don't know, man.
Really impressed right there for that one. You got concepts very well, very easily. And yeah, I mean, I don't know what else to say, dude. That was really good.
Yeah, it was pretty good, man. Pretty good. Yeah, I think you have like the logic part of stuff. I think you just work on a little bit syntax, and you know that happens.
Yeah.
That will come with time a little bit, you know. So that's why when it came to syntax, I feel like we could have been a little bit like we were a little bit more relaxed, because as long as you understand what you're doing, what you're trying to do, syntax is just like another like it's just something minor that you can easily fix up. And like Carlos was saying, you like showed really like excellent like concepts. Like you grasped the concept, you grasped the question, you were thinking, you know, really good like techniques and stuff. And yeah, man, I allow you. You're in a good path. You're in a good path.
Great path. Excellent path. Might be the best path. So, dude, we got Melanie Cruz saying Simon did amazing. Yes, Simon did amazing.
He did.
Thank you.
Perfect. I mean, I think that's about it. I'm gonna switch out to LeetCode on our solo faces.
Yeah,
and
man. I think we can.
We don't want to keep you any longer, Simon. Jose, same for you. I know you got bedtime. I'm gonna go find something to eat. I'm gonna go find something to eat right now. Simon, dude, we got better at explaining stuff. We got better at teaching. So thank you for allowing us to teach and maybe coach a little bit. And I hope you got a little bit better at whatever you're trying to accomplish, which is, I'm assuming, LeetCode and maybe just understanding how to solve problems. So I think it's a win-win for both of us. We learned more stuff. You learned more. Viewers that are watching maybe thought it was educational and entertaining, so that's always good.
Yeah.
So I think that's it. Any final words, Jose?
No, I think it's it, Simon. Thank you for coming, bro. Thank you for giving up your time, you know, and I know we went a little bit overboard, like an hour or so. So thank you for that extra hour, Simon. You did amazing.
Yes.
And yeah, man, hopefully this was very fruitful for you, and that helped you understand a little bit more, and eventually, and most importantly, helped you get like open the doors to LeetCode. That way, you know, we want to show you that it's not that scared, you know. You just have to go in there a little here or there and just figure it out little by little. And yeah, man, other than that, I'm good.
All right, next stream, next video, we might have another freshman joining in. By the way, so if y'all like this, please comment that you like it. If you don't like it, don't comment that you don't like it. Just only comment if you like it.
Yeah.
So, all right, I think that's about it. Let's get some more comments in the chat once the stream's done. All right, everyone. Y'all have a good day, good week, good everything. Thank y'all for joining. Peace out.
Yeah. Bye-bye.
Thank you. Peace out.
All right.